Hey everyone, and welcome to video number 3 of my Salesforce Lightning Web Components tutorial series that can be found here by going to this playlist. Now, as always, if you aren't familiar already with Lightning Web Components or how to get the environment set up, feel free to check out this playlist right here called Salesforce Lightning Development Setup. I'm kind of going with the assumption that you already have your environment set up and perhaps have even seen my previous Lightning Web Component videos because they kind of do build up on top of each other. But anyways, with that said, consider subscribing if you guys find any of this stuff useful. Feel free to leave any comments down below if you have any questions or there's any video topics you want to see me cover in the future. And I guess with that said, today I want to go over the track decorator and I guess by extension how arrays and objects work with data binding and displaying them on the HTML. And so with all of that said, let's jump into it. Here in my VS Code, I already have my dev hub set up and a Scratch org ready to go. And as you can see here, a Lightning Web Component kind of already set up just so we can kind of start not from scratch. But anyways, just to kind of walk us through what we have here on this screen, we have a Lightning Web Component called Track Decorator. We have a to-do list array property. And inside of the array, we just have an object, just one for now, with an ID of 1, a name of study LWC, and just a kind of like a timestamp, as well as a second property called new to do that's just going to hold essentially what the user is going to type in, and then at some point later we're going to go ahead and update with whatever the user puts in here and create a brand new object entry into our to-do list, as well as two methods here. The first method basically captures whatever the user types in into an input tag that can be seen here on the HTML side, and lastly an update to-do list method that will go ahead and push whatever the user wants to add to our to-do list. So nothing too crazy. And on the HTML side, like how we kind of already went over, we have an input. We have an input that's a type button. It has the value of add to do. When they click on it, it will basically call this method right here that will go ahead and update our to-do list. And towards the bottom, we have if I indent this properly, we have a template tag that will basically iterate through the to-do list and just display it so that the user can see what they're doing. So nothing too crazy. I know I'm kind of glossing over this, but that's because we already have two previous videos that went into much more detail about everything we're seeing just now. But anyways, this will basically look like this in our Scratch work. I've already gone ahead and added this Lightning Web Component to the home service page, so you can kind of see it right here. And basically this gets us to the point where we can start talking about the track decorator. So decorators in JavaScript, and I guess more specifically Lightning Web Components, they're essentially just functions that will wrap around something to give it more extended functionality. So for example, if we were to add a decorator to this property here, we would basically be giving it some additional capability. Now, the reason why this is important is because if we go to our Lightning Web Component here, and we were to basically try to add something to our list right here. So for example, if I wanted to say, okay, after we study Lightning Web Components, we want to perhaps go to the gym. If we click on the add to do, which should push this new thing to our to-do list array, we would expect it to basically be populated right here, right? We would expect to see a brand new list item added, but it doesn't, because the Lightning framework has I'm not sure if it's a limitation or just the way it was designed, that whenever something gets updated, so for example, when we clicked on the add to do button, this method was fired, right? Which basically took what the user typed in and then just added it to the to-do list right here. This to-do list was updated in the JavaScript, but because the Salesforce framework doesn't observe changes to complex data types, and complex data types are essentially arrays or objects, or I guess in this case, an array of objects, it's not going to go ahead and re-render basically these tags right here. It doesn't do that for us. Now, if instead we had something like this new to do right here, if we were to go to our JavaScript side and perhaps let's create a paragraph tag right here and just display this new to do property in here. So if I'm going to say something like, this is what you're typing, for example, If you go ahead and hit save on this and just push this to our source, to our Scratch org, just to kind of explain what I'm getting at. If we go here, refresh our page so we can see the brand new Lightning Web Component. If we were to type something out right here, like this is what I'm typing, you can see clearly that our Lightning Web Component is getting re-rendered and we're seeing what we should expect to see on the screen, right? Well, that is because by default, the Salesforce Lightning framework can observe changes to a property when it's being reassigned. And essentially what we're doing here, whenever the user types something into the input tag, the onKeyUp event fires and it calls the get new to do method right here, as we can see. And what this is doing is it's essentially reassigning, or rather updating the actual property itself. As you can see here, this .new to do is equals something brand new. And because this is just a simple primitive, it's a string, it's updating the entire thing. Therefore, the framework can basically see, oh, something changed. We need to go ahead and re-render it on the screen and so that the user can see something brand new. But the difference between that and the to-do list array that we're updating is the framework doesn't observe changes within the array, if that makes sense. So clearly this method is adding something brand new to this to-do list array, but the framework isn't by default tracking it, if that makes sense. Now, if we were to do something different, like for example, if we were to say, instead of, let's go ahead and set this equal to something brand new, in this case, then by definition, the Salesforce framework will observe these changes, right? Because now we're not adding something to the list, we're creating a brand new array list and we're redefining it to something else, right? So the framework should observe those changes and it should update the UI. So let's go ahead and kind of show that, right? Now, what we could do instead of pushing an element into the to-do list is we can just assign a brand new array in it, and we can make use of this thing called the spread operator. And it basically looks like this. So you do ... and then you pass in the name of something that you want to spread. And essentially what this is doing is it's telling JavaScript, hey, grab this or this array of objects and dump everything that array has into this brand new array. So essentially, because this array only has one element, which is an object, it's just going to dump this object in this brand new array that we're defining right here. And what we want to do now is, after that, we can go ahead and create a brand new object instead of this array that will contain the new thing that the user just added. So what I'm going to go ahead and do is I'm going to go ahead and just space this out so it doesn't look so bad. And in here, I'm going to do a comma, and then create a brand new object right here. So like I said, the spread operator is going to take everything that exists in the current to-do list and just add it to this brand new array that we're defining right here. And inside of this brand new object, we can add some key value pairs. So I'm going to say this new to-do that the user is adding is going to have an ID of something. And what I want to do is I want to make it dynamic. That way we don't have to worry about manually updating it ourselves. So what I'm going to go ahead and do is I'm going to grab the current length of the current to-do list. So we'll say this .to-do list right here, and let's go ahead and grab the length, and then we're going to add 1 to it, because essentially what we're doing is we want to get a unique ID for every single to-do item that the user is adding. So if you follow this chain of events, when the user first clicks on the add to-do button, the length of that to-do list will be essentially 1. So we're going to add 1 more to it, making it 2. And 2 is basically the second to-do that we're adding, and so on and so forth. So the ID will always be unique because we're always adding 1 to the current length of the to-do list. And then the name property can just be that to-do that the user filled out in the input tag. So we'll say this.new to-do like that. And then finally the timestamp, which we can say by just grabbing the new date and then just doing .to local time string. And I'm really only grabbing the timestamp. I don't really care about the date, at least in this specific scenario. So essentially what we have here is we're saying the to-do list is going to equal to a brand new array, and that brand new array is going to have everything that was already in the to-do list plus this brand new object here. And by definition, the Salesforce framework only observes changes to properties that are assignments or reassignments. And that's essentially what we're doing here. We are assigning something brand new to this to-do list. Therefore, the HTML should re-render whenever the user adds whenever the user clicks on the add to do button to update the to-do list. Hopefully that makes sense. But we'll go ahead and hit save, and then we'll push the source to the Scratch org. Once that is done, I'll go ahead and refresh, and then we can basically test this out. So we're going to say, after we study Lightning Web Components, we can do something like go eat lunch, something simple. We'll click add to do, and as you can see here, we added another item. Then perhaps let's try it one more time. So we can say, after we eat lunch, go back to studying for PD1, the Platform Developer 1 test. And there we go. As you can see, it is adding it to that list just fine. And then because we're doing a whole brand new assignment of that to-do list property, which is right here, the HTML, the framework, whatever it is, can easily re-render it for us. Now, what if we didn't want to do it this way, right? What if we didn't want to have to reassign a brand new array or a brand new object, whatever it is, every single time the user wants to add something or remove something, whatever it might be? Well, in that case, what we can do is, let's go back to our original example. So actually, let me go ahead and cut this out because we might need it in a little bit. I'm going to paste it down here, and then we'll just comment it out just for the time being. But basically, let's go back to what we had originally, which was this .to-do list. We were going to use the push method to add the to-do that the user created into this array, right? As we showed earlier, this wouldn't work without making use of the decorator called track. And as you can see here, I kind of got ahead of myself in between cuts, and I already went ahead and used the @track decorator on the to-do list array, and I also imported it right here, as you can see in this import statement, which is very important to do. If you don't do this, well, you won't be able to make use of the @track decorator. So once you do those two things, what we can go ahead and do is basically, let's go ahead and just copy or I'm going to go ahead and uncomment this thing we had right here, and basically just cut and paste it here. Now I'll go ahead and indent it so it doesn't look so bad, like so. But essentially now what we're doing is, instead of reassigning the to-do list array every single time we want to add something to it, or now we're going to make use of the .push method to just add something into the currently existent to-do list array. And because we're making use of the @track decorator, now we're telling the Salesforce framework to keep track of any changes to this actual property, whether that be a reassignment or adding a new element to it. So let's go ahead and hit save, and we'll push this to our Scratch org one more time just so we can kind of see this in action. I'll go ahead and refresh the page here. And now let's go ahead and add something. So we'll say, go make coffee, something simple. You click the add to do button, and as you can see here, same thing. It's still working just fine. So let's go ahead and try it one more time. Just go make lunch, I guess. And yep, working just fine. The timestamps are updating just fine as well. But yeah, I essentially just wanted to show you guys two different ways of basically getting the exact same result done. One being using the spread operator in conjunction with reassigning the entire property, and the other one being using the track decorator to tell the framework to observe changes. Like how I said earlier, after the Spring 2020 update, we only really use the track decorator to keep track of changes to arrays and objects. And when I say observe changes, I mean deep changes, right? So we wouldn't need to use the track decorator if, like how I showed earlier, if we were just reassigning the entire thing every single time. But if one little thing changes or we're adding a new element to the array, then you do have to use a track decorator or just reassign the entire thing again. So hopefully that makes sense. I think that'll be it for today's video. If you found this useful, like, comment, subscribe. I would appreciate that, and I'll catch you guys in the next video.